CloudDB, shaping your new normal.
Good morning, good afternoon, good evening, everyone, depending where you are around the world. Welcome again to the 2021 APAC Groundbreakers Virtual Tour by Apaco UC. This year, our event will be the biggest one ever done with 144 sessions, including normal sessions, workshops, and hands-on labs from 100 different speakers over 18 days. Also, it will cover sessions in 4 different languages. Please remember to register to as many sessions as you can. This way you will be able to have access to our replays until December 30. I would like to say thanks to our Oracle user group in Java user groups, all 16, that made this event possible, and also to our sponsors, Oracle Groundbreakers, and your main sponsor, CloudDB. Now for today's session, secrets, features of Oracle Data Pump, the underused and perhaps little-known features of Data Pump by Roy Swoger. Please feel free to ask questions at any time by using the chat window on your right lower corner of your screen, and Roy will be answering all your questions at the end of the session. If you have any issues or problems, please let me know by using the same chat window, and I will try to help you the best I can to solve your issue. Now, without any more further ado, I leave you with this amazing session by Roy Swoger. Roy, the room is yours.
Thank you, Francisco. Appreciate it. So welcome everybody to our talk. And this is going to be a little bit of a different talk when we're discussing Data Pump. And there aren't any really secret features of Data Pump, but we put that in the title because we think that there are some features that are really powerful.
Roy?
Yep.
Sorry. Looks like the sound is playing again.
Okay.
Again. Can you hear Roy properly, or it's just for my side that I hear him like cracking like a static one?
If someone in chat could let us know whether the sound is good.
That's what I'm asking.
Okay, we're not getting any. Let me try my other microphone.
Okay.
Okay, how is that?
It's still cracking, but it's a little bit better.
Okay, let me try one more. Okay, how about now?
It's better. Is the cracking is a lot lower? That helps.
Okay, I've shut off my video too, just in case it's a bandwidth issue.
Sounds good. Thanks.
Okay, so go deep into a few features here that hopefully you'll find useful. So my name is Roy Swoger. I'm Vice President for Database Upgrade, Patching, and Utilities. Data Pump falls under what we call database utilities, along with SQL Loader, transportable table spaces, the metadata API. And if you don't know what Data Pump is and you happen to wander in here by accident, Data Pump is available to enable you to move data between out of into Oracle databases, but it's proprietary format data. So it's not an unloader, it's not SQL Loader for loading flat files. It's about moving data between Oracle databases. The 4 features that we're going to talk about today, you see them listed here. And I'm not going to just go through them in topic order, but these are the ones that we will be discussing. And I'm going to talk about the first 2 together as part of a bundle that I'll talk about. Before we get into those features, I just want to set the context, because most people think of Data Pump as just being the export and import clients that you see at the top of this diagram. But Data Pump mostly lives within the server, and a lot of what we're going to talk about today are things that you do on the server. It has nothing to do necessarily with the client. So we'll talk about the DBMS Data Pump package, which is our tens of thousands of lines of PL SQL that implement Data Pump, the control process, the worker process, and so on. And you'll see how what you can do with that differs from what you can do with the client specifically. So the first thing I'd like to do is position this as a use case that you might have as a DBA, as a developer, where you might need to change the way that we import, especially import and index. So why would we want to do that? Well, since 12.2, when we import metadata with data pump, we import indexes in parallel. Before 12.2, what we would do is we would import one index at a time, and we would use the index's defined degree of parallelism from the create index statement to determine how many parallel query processes would be used to build that index. But what we found is that in databases with lots and lots of indexes, it was much faster to build multiple indexes at a time, with each one being built with a parallel degree of 1. So if you had parallel 32 and you have 2,000 indexes, we would build 32 indexes at a time, each of them using just one worker process. Well, that works great for most cases. But for some cases where you have real skew in the size of your indexes, you may want to have one or two of those really big indexes built with parallel queries still. Because what could happen then is if you have one monster index and say 3,000 small indexes, that one monster index could take as long to build as the entire rest of your import. So we're going to show you a way to deal with that as a way to talk about two features. And those two features of how you would go about changing the way you import something are the SQL file parameter for import or the metadata API. So here's a case that I built in our little hands-on lab database where in this particular schema, I only have 7 indexes, but you can see that one of them is orders of magnitude bigger than the others. Now, if I just imported this schema, each one of those indexes would get one and only one worker process to build the index. And clearly that might not be the most efficient way of doing it because we might want to use parallel query on that big one, IDX1. So the first thing I've done is kind of looked at my database and said, well, what are the relative sizes of the indexes in my source database? If they were all small, I wouldn't worry about it. But in this case, I know that I have a big index that might dominate my import runtime. So here's method number 1 for how you might deal with that. And we're going to use the SQL file parameter for data pump import. Now, what the SQL file parameter does, if you've never used it, is that it will generate a SQL file, an executable SQL file of all of the create and alter statements that import would perform when it's importing the dump file. So every individual piece of metadata, every user, trigger, constraint, table, and yes, index will be in that SQL file depending on how you define it. And what will also happen is if you use an example like we have here, where I say SQL file equals create index.sql, is it will prevent the import from actually running. So it's kind of doing a dummy import where we get the information about everything that will be created as part of that import. Another important thing here is if you look at the parameter file, I've included just the index that I'm interested in. So remember, we saw that IDX1 was the big index. So what I'm doing here is I'm going to get an executable SQL file which contains only the information for building that index and its dependent objects, like its index statistics. Now, it's really important for a lot of these cases, as you see in the pro tip, use a parameter file when you're going to be doing this kind of filtering, because all of those double quotation marks, single quotes, putting those on a command line, it can be really kind of a pain to figure out how to get those special characters to work correctly depending on your operating system. The way you have an escape character on Windows might be different from on Linux or whatever. So by using that parameter file, I generate a SQL file that has the create and alter index commands for this particular index. And here's what you'll find as part of that SQL file. Now, we'll actually have a lot more in there. There's some events being set and some other context that you would want for executing all of these commands. But the create index command and the alter index command are just like this, copy and pasted exactly as you see here. And here's what I mean about how data pump would normally import this index. You see it is being imported with parallel 1, and then after the import, we alter it back to its original degree of parallelism. So that serial import in this case is probably going to be pretty slow for this index, which is very large. So that's one way to get the information to rebuild this index. The other way to do it would be to use the metadata API, which is the DBMS metadata package. It's listed in the PL SQL packages and types manual, and it has a whole bunch. It has literally dozens of sub-programs within it. Most of those sub-programs are going to be used primarily by data pump itself, but we use it to extract metadata, to manipulate it. It's related to the DBMS metadata diff package. We can take two pieces of metadata and find the differences between them and all of that other stuff that we might need to do to import from one version to another, from one database to another. But you can use it as well. And the get DDL procedure in particular is really useful for what I would call a casual user, someone who just wants to find out information about an object, and maybe you can look at it and see, well, hold it, this is acting weird. Why is it behaving this way? And the get DDL procedure might give you some clues there. So here's an example of that, of using it. Going in, setting some formatting, usually pretty important when you're dealing with these long creation DDL statements, is we select, and it's called as a function, so you're doing a select DBMS metadata.get DDL, not exec DBMS metadata.get DDL, but you specify the type of object you're looking at and the name of the object, the schema if it's not within your schema, but we don't have to do that here. And it will give you exactly what you see here. Again, this was just copied and pasted from terminal output, no reformatting needed. And here again, you see the create index statement for this index in the original database. And once again, you see that the original degree of parallelism here was 4. So if we wanted to import more efficiently in this case, we have two approaches that we can use. And it depends on whether you're starting with the dump file on the left, or if you can start with the source database on the right. Either one can work for you. So step 1 of using a dump file, you identify the objects you want to change, like I did earlier with that query from user segments to find which of my indexes were the biggest. Well, that's the same step if you have the source database as well. You need that source database in order to identify the object, no matter what. Then if you're going to use the dump file, you would run import, but use the SQLFILE parameter so that you can see the creation and alter DDL that is part of the import job. If you're instead using the source database, then you would use DBMS metadata to get the creation DDL for that object. If you're starting with the dump file, you would then edit the SQLFILE output, take whatever parts of it you want. It could be one index, it could be multiple. And then you could edit that and change the parallel keyword in the create index statement. Or you could just get the original create index statement from the source database. And then the key is when you do your import, you would exclude that index. So you're going to import everything except for that one index. And you do that in either case. And then immediately after the import, you can just go into SQL+, take your create index DDL, and execute it. So this is a typical thing that you might need to do if you've got that 1 or 2 really big indexes that would slow down an import, but could be done much quicker after you've got all the data in place and you can use parallelism for the index build. So that was, I hope, an effective way to contrast 2 different ways to get the metadata or the creation statements that you might see from a data pump import. Because data pump imports can be time consuming and usually you'll want to optimize the speed. Let's talk about the next feature that we want to delve into. And this is all about using data pump at the API level instead of using it at the client level. You saw the metadata API. That's used to extract metadata from the database. The DBMS data pump API is used to create and execute and monitor jobs for data pump. So it's not being used to directly move the data, but it's used to create jobs and manipulate them and set them up and all of that. So the export and import clients for data pump actually call the DBMS data pump API to do all of their work. Our clients are very thin clients. All they do is validate some parameters and then make some DBMS data pump calls to the database. So they're not doing a lot of processing, unlike, say, the SQL Loader client or the old export and import clients. But because those clients are just calling the DBMS data pump API, well, so can you, because it's, again, just a regular PL SQL package that's documented in the PL SQL packages and types reference. To get a sense of what it means to use the API, let's compare a simple export statement with what you would do to set this up and run it in the API. So we'll go through that, and then I'll show you a reason why you might want to do something like this, an example of using it, maybe a little more, a little more useful example. So here you have a simple export command. What we're doing is we're just exporting from the system schema, which isn't going to have a lot to export really, but we give it the basic information like the directory object, the log file, the dump file, parallelism, and then we're going to add a couple of useful parameters for metrics and log time so that we could get good output. So how would we do this with the data pump API in a PL SQL package or an anonymous PL SQL block? Well, what I'll do is I'll highlight the aspects of the client statement on the left and show you the equivalent in an API call on the right. So the first thing is just to denote the fact that this is an export job. But as part of opening the job for the data pump API, you tell us, is it an import or an export? And then what mode is it? So that means, is it a table mode export, schema mode, or a full database export? So our job mode is schema in this case. If it was a database link, a network mode access, you would have to put something in for the remote link. And you can give it a job name or not, depends whether you want to. I always like to have a job name because then I know where the master table is. I know how I can connect to it and monitor it. And then you don't have to specify version. It will default to current version for the export. So that's the open call. It sets up the job. And then we want to add some things to it. Like we said it was a schema mode job, but we didn't say what schemas we were exporting. That's the next step here, is we can add what we call a metadata filter. Metadata filters are extremely powerful. You can specify exactly which objects you want to export or import using one or more filters. You can have a whole bunch of filters in a job if you want to. And in this case, what we're saying is this particular filter is a schema list, and you see what, or a schema expression, and we can put one or more schemas into that expression. In this case, we're just using a simple in query to say that the schema that we want to export is the system schema. We could have a list there. We could say system, comma, Scott, comma, whatever. So metadata filters can be used to specify schemas, tables, or even other object types. You could get very specific, saying, I want to get statistics or even table statistics or index statistics, or I want user grants or something like that. A lot of power in those metadata filters. A couple of other things that we need to specify for our job is what are the dump files and where do they live? Now here it's two parameters on the left. It's one call to add a file on in the data pump API, because when you include a file as part of a job, you have to tell us the name. You can use wildcards. You have to tell us the directory in use, and in some cases you have to tell us the file type. Now the file type would default to dump file, But I want to be specific here just so it's clear in my code that this is the dump file that I'm specifying. Because we can also specify a log file. And that's what we're doing this second add file. So notice it's the same call, add file, but we're using the type of the file to specify dump file versus log file. And then finally, the parallelism. Well, not finally. The next step, we can specify parallel. Now, that's a specific call, is to set the parallelism of the job. And we just give it a number here in this case. And if you wanted to, this shows you a little something that you could do with the API. You can actually have it set up to, within your PL SQL block, to get the current number, how many CPUs do you have in the system, and use that as parallel, or use a fraction of it if you wanted to. Whereas from the command line, of course, you just have to specify the number. So that gives you just a hint of the kind of processing you could do in your PL SQL if you wanted to be able to change things dynamically based on your system environment. And then for things like metrics and log time, there's a set parameter call that can be used to set a whole bunch of parameters in data pump. And for each parameter you want to set, there is you would call that specifically. And this is an overloaded function call. By that I mean you have multiple versions of it where the value can be a number or it can be a varchar value. Because some parameters take text as their value, like you see here, all for log time. The same would be true of like table exists action. You could have it as replace or truncate or ignore. Others have numeric values, like you see here for metrics. Even though on the command line you would say metrics equals y, in the API it's metrics equals 1 or 0. So that's how you would use that. So let's look at an actual example, and this is kind of an interesting example. Again, shows you the type of things that you can do with the data pump API that might be a little more difficult or that might be a little clunky to do with the clients. And what this is a very small procedure that would essentially back up a schema within the database. And what it does is it uses a DB link. So outside of this schema, that's why I have it in red, the remote link there. We've created a database link that points back to the same database. So what this procedure does is it uses data pump network mode to create a copy of a schema with a slightly different name. So what we do is we start by prompting for the schema that you want to back up, and then we append to that schema name _BKP for the backup location. We open the job using a remote link, and then we set up a couple of things here saying what schema are we going to be importing. We remap the schema to the new target, and then what we will do is replace any tables that were already there, because you might be backing up the same schema multiple times and you want to overwrite the tables that are there in case they've grown or been modified, and then you just run the job. So if you want to see how this would work in action, I just did a little video of this. It's actually pretty boring to watch, because what you would do is you connect, in this case, as system. You get prompted when you run this little backup schema script. It prompts you for the schema name. Now what you see there is I've uppercased it to make sure that it will match when I do the schema filtering. And then it just runs for a little bit. I did speed it up there, but in this case, a small schema, maybe 30 seconds. In the end, you can look at the log file and see what happened as part of that PL SQL job. So that's a kind of utility thing that you can do with the data pump API. And there are really a lot of uses for it. Oh, let me mention here the comment here is Rodrigo Jorge, who's a product manager in the Upgrade team. He's a senior principal product manager based out of Brazil. He had a really good example that I stole for this, and I kind of updated it a little bit, but he talks about how to use the API in this case with the loopback and all that. So Other things that you might want to think about doing, and some of the things that my product managers have done, especially in previous lives. First of all, the DBMS Data Pump API is how we integrate Data Pump into our Oracle supplied tooling, like Enterprise Manager's Migration Workbench or ZDM, the Zero Downtime Migration Facility. It's very useful for building a scheduler job. One example is you could have a scheduler job that every hour it would wake up, look in a directory to see whether a dump file is there, and then import it if it existed. That kind of stuff works very well with the API with PL SQL. You can build jobs on the fly with interactive input, as you saw here. Now, PL SQL does not have really robust facilities for bringing in input or for putting out statements, but you can, of course, also wrap it in other languages and 3GLs and have your PL SQL package, for example, in the database called by a C package to do that kind of stuff. And that means that this is very useful for custom tooling. So you might have your own Ansible playbooks that want to call things, or you might have your own programs that you've written that then can call into the database PL SQL packages that would then invoke Data Pump. So hopefully that gives you a taste of how you could use Data Pump. There's a lot of things you can play with there. I whipped up all these examples just over the last couple of days, just kind of looking around and thinking about what are the kind of things I would want to do. But there's a lot more power than I could put into a presentation. So the last topic I want to talk about it's a relatively new one, and this is the best way to do your patching for any Data Pump user. And what we're going to talk about is the Data Pump bundle patch. Now, what the Data Pump bundle patch is, it's essentially just a merge patch. And anyone who's had to request a merge patch, you probably know what those are. It's a bunch of patches put together. But this is a very special one. And the reason that we created this Data Pump bundle patch is that Data Pump fixes do not go into our release updates. And the reason that they don't go into release updates is that when we're creating and replacing PL SQL packages, that action is not really rack rolling installable, because if someone was running Data Pump while we were trying to create or replace a package, then the create or replace would fail. It would time out after 3 minutes, and then the patch wouldn't be applied. So what we do is now we have a separate patch for Data Pump that includes not just the most important fixes that we have in a big bundle. No, it's not that big. It's a couple of dozen fixes. But it also includes, since 19.10, the complete overhaul of the DP load script and all the scripts that are used to rebuild Data Pump. So when you apply a Data Pump patch, generally what we're doing is we're replacing PL SQL packages such as the worker package or the metadata API package, or adding new style sheets to change the way that different DDL statements are handled. And then we reload Data Pump to the degree that we have to. Whatever has become invalid gets rebuilt. And it used to be that rebuilding Data Pump could take 3, 4, 5 minutes when you're patching. Well, with this overhaul of the Data Pump patching, it becomes much, much faster. I'll tell you how much faster in a second. So first, let you know that we have a Moss note on this that everybody should have as their favorite, and that will tell you the recommended patches for each release update from 19.10 onwards. So 19.10 is now about a year old. So hopefully you're on a newer release update now, but if you're not, you should be moving up to these release updates and using this bundle patch. So what does a bundle patch do in terms of patching? Well, I mentioned it was faster. It's 60 to 90% faster than the old dpload.sql script for Data Pump. So whereas it used to take sometimes 3, 4, 5 minutes to patch Data Pump, now it can take as little as 10 or 15 seconds to apply a Data Pump bundle patch. Another benefit is that there are many fewer invalid objects the first time you run this new patch, and then after that there will be 0 invalid objects due to data pump patching. So you won't have to recompile objects afterwards. It's just much more robust. And that lack of invalid objects is of course good for anybody who's using data pump, because it means we won't have to recompile objects on the fly after we do the patching. Because it's faster, and because it only rebuilds the parts of data pump that need to be rebuilt instead of rebuilding everything from scratch, it makes patching data pump much less contentious with other activities in the database. And the biggest benefit of this to me, although these are all pretty good, is that this new data pump bundle is available the same day that the release update comes out. So when 19.13 became available publicly on each platform, there was also the data pump bundle available on each platform. So how do you get it? Go to that Moss note and you'll find which patch you need, and there will be a link to the data pump bundle for your release update. It also lists every patch that is included in that release update. It does grow with each one, because what we've tried to do is we select the most important fixes and add them to the bundle with each quarter. We're not trying to make this 100 patches or something like that. But when we find that there is an issue that maybe 10 or more customers are hitting, we make sure to add it to this bundle. And then how do you install it? Well, this is the really cool thing. This patch bundle is what we now call a non-binary online patch. It's probably not terminology you've heard before, but what that means is that you can install it while your database is up and running. I'm not even talking rack rolling install. You could do this on a single instance database, because the only patches included in our bundle are PL SQL and XSL style sheets. We're not changing any of the binaries. It's only the PL SQL packages and procedures, the XSL style sheets. So that can be done while the database is running with one condition, and that one condition is that nobody can be using data pump. So in some ways, it's actually much better than rack rolling, because you can use it on a single instance database. You don't have to have any downtime at all. But the one condition, again, is that nobody can be using data pump when you try to do this patching. Now, if you're worried about that condition, well, we have some safeguards in place. It's a two-way street here. What will happen is when we go to patch data pump, we try to get an exclusive lock that controls data pump patching. And when anyone tries to use data pump, like export or import or use the metadata API, they get a non-exclusive lock, the same lock. So if we have the exclusive lock, no one can start data pump. And if someone is using data pump and has that non-exclusive lock, well, the patching process won't be able to get its exclusive lock, and it will give you an error message. So here's what you'd see right now. Let's just say someone is in the middle of performing a data pump import, and you go try to apply the data pump bundle patch to your database. What will happen is the data pump bundle patch apply will hang for 3 minutes. We have a built-in timer there, just in case whoever was using the data pump was just doing something really quick. We don't want to die every time for no reason. So we have a 3-minute timer. If it's still in use after 3 minutes, then you would see this error message here. This is a pretty informative error message. You may not look at it like it at first, but if you see what's going on here, it says you can't run the DP load script right now because data pump and the metadata API are in use. And then it actually tells you which users are locking the data pump objects that we would need to patch. So in this case, you get the process ID, the username, the machine ID, if it was relevant, and so on. So this gives you as a DBA the information to maybe go to a user and say, I see you're doing an import right now. I really need to patch data pump. Let's pause your job. We can restart it after the patch, but I really want to get this patching done. So hopefully we're giving you enough information to really give you control over your environment. So that's the one way. But what if we're applying the data pump patch and then someone tries to start an export or import? Well, in that case, they would get this set of error messages. Now, I will say this is not a very informative error message. But what we've done in 19.14, which is going to be the bundle for the January release update that's coming out in a month, when that release update comes out and you get that bundle patch, we will get a much more informative error message here. But again, we prevent a data pump job from starting if patching is underway, because we don't want someone to try to use data pump when some of the packages are in an unknown state or where everything hasn't been completed yet. So we built these safeguards in so that you can apply this on a running database. So those are the topics I wanted to cover today. I know I'm a little short on time. This is the first time we've ever delivered this talk, so it went a little faster than I expected, even with the technical issues here. But I'll just wrap up by mentioning a couple of resources that you might want to know about. One is our recorded web seminars for upgrade and migration of Oracle database. We have 11 of them now, with the most recent one being actually just delivered today at 4 in the morning. 4 in the morning my time. It was a good time of day for Europe. But today's was about migrating very large databases, 100 terabytes or more, and that might be very interesting to a lot of people. In March, we have another webinar, and that one will be a very deep dive into data pump. So this was just about 35 minutes or so, but we're going to spend 2 full hours on data pump in March. So we have a series of what is currently 11 webinars. It will be 12, and it's all available on demand, and you can get them from the Upgrade blogs. We also have a YouTube channel, where we take a lot of our videos and we break them down into bite-sized pieces of usually 3 to 8 minutes, sometimes even much shorter than that, where we take a single topic and just show you quickly how to do something. And whether it's something like something for auto upgrade or performance stability or any number of topics about upgrade and migration. And finally, the main upgrade blogs, MikeDietrichDE.com, DOH Database, that's Daniel Overby Hansen's blog. I actually have to add in Rodrigo Jorge's blog into our slides, but that's another one that is very useful as well. So with that, I'm done with my slides here. Let's see if there are any questions that we can answer. I'm going to stop sharing my screen here.
Hi, Roy.
Hi, Roy.
Yes, excellent presentation as always. And just to give some time to see if anyone has any questions, and also through here and through Facebook. Saying that, thank you again for the excellent material and information, and also for sharing with everyone the tutorials that your team have done, all the blogs, the videos in the YouTube channel. Is a lot of content that your team works hard to keep helping the community with all their questions and regarding all your products and services. And let's see, no questions looks like are coming. If that's the case, everyone can basically contact Roy and the team by the contact information that Roy shared in the presentation. And you can contact Roy on his email, on his Twitter handle, Mike and Daniel too, and Rodrigo Jorge now. And if you're watching the replays, you can also contact them offline with no problems at all, and the team will be more than happy to answer any questions you could have. If you cannot get in contact with them, you can also get in contact with me, Francisco Munoz Alvarez, or any one of the APAC team, and we can relay the questions to Roy and his team. All right, and saying that, thank you so much, everyone. Have a wonderful good morning, afternoon, or evening, depending where you are around the world. And please take care and be safe. Thank you so much, Roy.
Thanks, Mike.
Bye-bye.
CloudDB, shaping your new normal.